right, ladies and gentlemen, welcome back. We are picking up part 2 of our Introduction to Global Studies notes. For those of you who missed yesterday, please note the other video. It is online on YouTube. If you need the link, let me know, as I know sometimes the link doesn't work on Schoology. Also, I hope you noticed that this video should be a lot better than the previous. I filmed the last one in 240p resolution, this in 720, so hopefully a huge step up. All right, for those who may have missed it, above me, I've got our worksheet that we're currently working on right now. Now, yesterday we did most of the stuff. We talked about like what is social studies. We talked about what this class is all about. Global studies is a study of time and space. Now we studied what like the definition of history, prehistory, generalization, bias. We're talking about primary and secondary sources. Also yesterday, we got to the space portion, or rather geography. We talked about what is geography, civilization, and agriculture. And that should get us to our next portion. All right. Let's continue on. All right, so within geography, you guys are going to know that a lot of these terms are kind of basic. You already know what they are. This should be fairly easy for you. So first things first, we've got the 4 cardinal directions. Yes, that's the proper name. We did not make it up. It's not a Newton cardinal thing. It is the term. So we've got north. We've got, let's see if I can do this in reverse, east, south, and west. Right? Right. Okay. More importantly, you can see that compass right above me, the directions, and you see on your worksheet you have a smaller compass. So go ahead, if you've ever been confused on which directions are which. I know that's quite a few people. We kind of don't ever want to talk about it. Now is a great time to jot that down on this paper and get a good idea of the 4 cardinal directions. Now, just so you know, these directions are relative to where we are. They're man-made constructs. They're not actually that real. Basically, it's our way to kind of find out on the whole world where it is we belong in relation to one another, and the 4 directions on 2 different axes help us describe those things. So we got north, south, east, west. Because of those directions, it helps us plot parts on the Earth, giving us places like the poles. The poles being at the very far north and very south of our globe. You know what? I am covering up the notes, aren't I? Let's see if I can. No, not that. There we go. I shrunk myself. Okay. Directions help us also map large things on the world, such as like with globes with latitude and longitude. For those who are unfamiliar with the terms, latitude and longitude kind of give us a grid on the Earth. Now, unfortunately, the Earth is a spheroid. Grids are usually on flat surfaces, so we got to kind of change things around. Let's see how we are going to do that here. So with latitude and longitude, latitude lines are the ones that run east-west but measure north-south. They're called parallel lines. So on your note sheet, you'll see we've got 2 circles there. Go and fill in that top one, latitude. And those lines will run east and west, or as we would look at it, being like horizontally. And we call that because then this line and that line and that line tell us how far north we are, opposed to these horizontal lines measuring how far south something is. Longitude is going to be the exact opposite of latitude in almost any way imaginable. They run north and south, and they tell us how far east or how far west something is. Note that latitude lines are parallels, longitude lines are not. All the math nerds out there are getting really excited because they know something here. They know that parallel lines are 2 or more lines that will continue indefinitely in both directions and never get closer or farther apart from each other. They'll always maintain the same distance from each other. Longitude lines, on the other hand, or meridians, don't do that. In fact, every single line of longitude meets at the North Pole and meets at the South Pole, kind of like the segments of an orange. They start together, they get really wide at the equator, and then they meet back together again at the other pole. Put those together, and we've got a really neat grid system that tells us how far north or south, east or west something is relatively on our planet. Now, I mentioned there are some exceptions. You guys will note on the globe, right at the North Pole, if I were to put my feet directly right next to each other on top of the North Pole, those feet would touch every single line of longitude on Earth at the same time. While, of course, latitude, the ones that run east-west but measure north-south, they would never touch. They're always an equal distance away from each other. So if I were to stand on the North Pole, direct north, like touching all lines of longitude whatsoever, I got a question for you. I want you to think about this. If I were to take a step towards you, towards the camera, what direction did I just go? Okay, I take a step back onto the North Pole. Now I go this way. What direction did I just go? Back onto the North Pole, feet right on North Pole. Take a step this way. Which direction? Okay, so you thought of that one, thought of that one, and you thought of that one. Now, I take a step this way, towards my books. Which direction is that? Now, some of you are sitting there rolling your eyes saying, I know this one, Mr. Weeks. Others of you may have just got tripped up. You were good at that direction, that direction, that direction, but I went that way. Some of you might have thought it was the same direction, and I went that way. That's right. If I'm standing on direct north, you think I go that way, it's to the south. You think if I go that way, it's to the east, and that way to the west. Or east, west. I don't know. The camera is throwing me off right now to what you guys see. Anyway, and then you went that way, like, oh, that's south again. No, but that way was south. And then you have to pause and think, wait, if I'm on direct north, my feet touch every line of longitude on Earth simultaneously, there is no more north. I have become north. I can't go north anymore. So technically, every direction opposite of where I am is south, whether it's that way, this way, or that way, because on direct north, there is no east or west, because north doesn't exist anymore. I am north. I cannot go more north than the North Pole. So again, these directions are kind of human constructs, and there's some exceptions to the rules. Same thing on the South Pole. If I stand directly on the South Pole, the only direction I can go is north. Once I take a step off to the north, then I've got east and west. Otherwise, those just do not exist. All right, so if you haven't done so already, you can pause the video to do this, but on your two circles on your sheet, please make sure the latitude lines, you add the lines that run east-west but measure north and south. And the lines of longitude, you write the ones that run north-south but go east and west from there. While you do that, I will go and scroll down. All right. So next thing we're going to be talking about are the climate zones. Climate zones are important because they kind of give us an idea of where we are on Earth relative to proximity to the equator. Why the equator? I'll get to that in a second. So climate zones. Because of the Earth's tilt, rotation, and the land-sea distribution, it affects some of the global weather patterns we observe. Now, while weather varies from day to day at any one location, over the years, the same type of weather will reoccur. This reoccurring average weather found in any particular place is called climate. Now, there's a big difference between weather and climate. Weather is what's going on outside my window right now. If I look outside the window, the temperature, the wind, precipitation, that is the weather. It's what's going on at this moment, at this time and place. Climate is like the general average weather of what it tends to be over many, many years. So living in Iowa, we live in a climate that typically year in and year out, we've got cold, dry winters, hot, humid summers, and in between seasons of spring and autumn that kind of mesh the two together. And ultimately, we have 4 different seasons. So our climate would be a temperate zone because it experiences all of those. If we lived in a place like southern Mexico, which is in the tropics, they have basically a hot and dry season and a hot and wet season. Now, again, this is southern Mexico, not northern, close to the U.S. border. They're maybe subtropic, if not even close to temperate. But anyway, so climate zones. Climate is the average over time. not what the weather is doing outside. So when people talk about climate change, they're talking about the change of overall averages and what's going on the large scale, not day to day. So just because you can find a snowball doesn't necessarily mean that the general warming of the planet isn't mathematically happening over time. Now, most people don't debate that. They usually debate whether it is caused by man-made influences or just normal like planetary oscillation. If you would like to go into more of a debate on that, by all means, talk to a scientist. I like to talk about history. So just telling the difference between weather and climate when we talk about global studies. All right, so we have got 4 climate zones. You'll see this on your note sheet. So, and these are just general climate zones. I'm pretty sure depending on who you talk to, there's a lot more or maybe even less than that. But for the sake of this class, we're going to focus on just 4 major climate zones. So looking at the Earth on lines of latitude, the ones that run east-west measure north-south, the 0 line of latitude is the equator. If you look at our map, there we go. Map over there, you can kind of see that line in the middle. That line is 0 degrees latitude. And from 0 degrees latitude to 23.5 degrees north and south, we've got the tropics. So anything from 23.5 degrees north to 23.5 degrees south, including 0 in between, all that middle section is the tropical zone. Now from 23.5 to 40 degrees, we've got subtropics. 40 to 60, getting further away from the equator, we got the temperate zone. We talked about that earlier. That's where you and I reside. And then, of course, the cold zones, whether it's Arctic or Antarctic zones, that is from 60 degrees all the way up to 90 degrees. And anyone who knows math knows 90 degrees is a perfect right angle, which would take us to the north and south poles. Now, give you a moment. If you didn't jot that down, please pause the video, jot that down now. So 0 through 23.5, tropics. 23.5 to 40, we've got subtropics. 40 to 60, temperate, and then 60 to 90, the cold or Arctic, Antarctic zones. Now, something you'll notice whether we're talking about the north or the south hemispheres of the Earth is that if you live along 2 similar lines of latitude, you tend to share 3 important things. We've got climate, length of day, and vegetation. What I mean by that is looking at this map up above me, see the red areas that are kind of like in Mexico and North Africa, parts of the Middle East and Eastern Asia. If you look on the southern hemisphere towards the end or kind of like the middle section of South America, the tip of Africa, and the bottom half of Australia, those are all subtropical areas. So whether in the north or the south, if you live in those regions, chances are you'll have similar climate, length of day, and vegetation as those other red areas. Just like the brown regions. The brown regions are the temperate zones. That's where we live. Most of Europe is in there, and most of Central Asia is in there as well. So you'll notice that we have similar vegetation, like crops and animals that we grow are very similar in all these regions. Similar length of day, meaning from sunrise to sunset, the number of hours we have of daylight will be the same. And climate, the average weather over time. Now, obviously, I understand seasons exist. So when we're in the northern hemisphere, it could be summer right now, while the southern part has winter. I get that. But what I'm saying is 6 months from now, when they're in winter, their winters, summers, whatever, their seasons are going to be similar to ours. They won't experience them at the same time, but they'll be similar when they experience it. So if you ever decide to go to the southern tip of Africa in the wintertime, it's going to be a similar wintertime as if you were in like Missouri or Arkansas. Still cold and relatively dry, and summers pretty humid and hot. Same goes on that east-west axis, but you guys can kind of figure that out, how most of Europe and the United States have very similar climate zones depending on exactly where you live. Now, of course, there's exceptions. There's always going to be like mountain regions. There's always going to be proximity to oceans and major lakes. And those things also have huge impacts on weather as well. Anyone who's ever been to places like Chicago knows that Lake Michigan does play a role on the type of weather they have that's unlike really any other major city in the Midwest. Same thing with the coastal areas of the United States. East Coast, West Coast, right off the ocean, they're not going to experience the cold weather that you and I do in the heartland of the Midwest. All right. Whoops, accidentally highlighted. No, don't do this to me. There we go. All right. Now this next part, we're talking about maps and globes. You'll kind of notice on our worksheet, as I scroll down, you hopefully got the 2 points of latitude, longitude, or 2 points of latitude, share, length of day, climate, vegetation. You'll note we kind of run out of notes. So this last part is more or less just kind of for your information, some background knowledge. So I'll zip through this relatively quick. Maps and globes. Why do we use maps and globes? Now, ultimately, globes are best. This is global studies. I would love if we all could study the globe. Unfortunately, globes aren't practical. They're very large, they're awkward, and you couldn't really bring one in and out of class that well. So we tend to use maps. Maps are infinitely easier. They're flat, they're relatively portable, and now in the digital age, they're really easy to have on flat surfaces. But here's the problem. Flat surfaces are not round, and it is impossible ever to represent a round object on a flat surface. We'll always have to kind of warp it, unwrap it, cut it up, divide it, and it's never going to look right. And even though maps are very useful, they're never perfect. In fact, they cannot be perfect. They will not be a good representation of a round surface because they are in fact flat. So we deal with different projections, which is the transformation of a 3D sphere object to a flat surface. Now there's many different types of projections that we can use in this class. Some are like one of the most famous ones, the Mercator projection, or a cylindrical. You can see on the image over there, it's kind of like if we just took a normal map and wrapped it around the globe. The grid system would translate well, but if you look at the grids, notice it's a perfect grid. Those lines of longitude, yes, the lines that run north-south and measure east-west. Ladies and gentlemen, you're gonna have to have those memorized. You just gotta know which ones they are. But remember, they're supposed to touch at the North Pole and touch again at the South Pole. On that map, they most certainly don't do that. In fact, look at the width of the equator. That's the only right part about that entire map. Because the further away we get from that midsection of the equator, the more distorted it gets. When we get to the North and South Poles, note how wide that is. That's supposed to be small enough my feet could step on top of the North and South Pole, and yet it's just as wide as the equator. Hence why on Mercator projections, like on Google Maps, they're insanely distorted away from the poles. So this is good if we're looking at maybe lines of travel, or if we're looking at the equator, but other than that, it really kind of fails a lot of tests. Just realized I left this here filming the entire time. It's really good aesthetics, isn't it? Other types of projections you can have, like the Gall-Peters projection. This one is kind of like the Mercator, but it distorts it. So I was talking about how the equator is perfect, and you get far away to the poles, and the Mercator gets bad. The Gall-Peters tries to compensate for that for kind of scrunching together the equator and elongating the poles. So the space is accurate, like the mass area is accurate, but the shape is definitely out of whack. As you can see how scrunched countries like Russia and Canada are, while places like South America and Africa, who are on the equator, really kind of get elongated. So you have a better idea of size, just the shape is wrong. The next projection, the Robinson, kind of tries to combine the two, a marriage of the Mercator and a Gall-Peters. It's still a bit off, the poles don't meet, but at least it's better than what we had before. And okay, this headache right here is really cool. This is as if someone had a globe and they took a knife and they stabbed the parts of the globe. They stabbed parts of the globe, especially around the oceans where people don't live, because this is social studies, not science. I don't care about the oceans because people don't live there. Sorry. I care about whales. I care about, marine life. But when I mean I don't care about oceans, I mean for the sake of studying geography and where humans live. We don't live on oceans, so don't care. We cut up all the oceans to leave the land masses relatively in the proper shape. And when we do that, we get a much better idea of how the continents really are connected. Because most of our Mercator projections really makes us think of the Earth as an east-west kind of alignment. If you ever traveled or flown around the world, you would know how often we truly utilize the North and South poles to move around. We can see how close the land masses really are to one another. There's other ones like the Mulvide, again, trying to combine different maps to get something that's better looking. And oh my goodness, ladies and gentlemen, this map is a good indication of your map and then your map on drugs. And this one clearly has made some poor life choices. Let's try to find out what's going on here. In fact, if you're not getting a headache, if you take a closer look, there's actually 3 maps here on top of each other. That's right, 3 different projections of maps put on top of each other, focused in the center, in the middle of nowhere, guessing probably around Wichita, Kansas, to find out how distorted things can get. Now, if you look at the red portion of this map, that is on a Mercator, or a cylindrical projection. You can tell because the border between Canada is a straight line east and west, which in actuality, it is. Our border with Canada is on a line of latitude and is a perfectly straight line east and west. So with this Mercator projection, it gets that right. But you've probably seen a lot of maps like the blue one, a more of a conic projection, where it's got that curve where it kind of looks like Washington is much higher north, so is Maine, and Minnesota is kind of in the middle of this like dip looking thing. While in actuality, the red one is more accurate. The very northern tip of Minnesota is just as far north as Washington and more north than Maine. Maine is not that far north. But because of different maps, different projections, people get different ideas. Look at Florida. On the green and red map, their projection of where Florida exists is completely different than the blue one. So depending on what map you are, if you're in a plane and you're going off of angles and going straight, you might miss Florida entirely if you're looking at the wrong map. So that just gives you kind of an idea of there is no really right or wrong map. It just depends on what you're trying to do and what you're trying to get accomplished. So, ladies and gentlemen, you will see at the bottom of our note sheet, I cannot see it, so I have to move it here. Okay. At the very bottom, I've got some of the core standards that we're using here. So ultimately, when we're all done this map, there are some things that we're going to move forward and focus more on. And that includes, we're going to determine multiple and complex causes and effects of historical events within our world history. And we're going to employ maps to display and explain the spatial patterns of human and environmental characteristics. So now that we've been introduced to all the basic terms we're going to know in global studies, we're going to have an idea what we're going to do with these terms. We're going to find how there's cause and effect of historical events in world history, and also we're going to see how maps help show how humans impact and have been impacted on the environment and where we are. So that concludes day 2 of the lecture. Ladies and gentlemen, if you have any questions, any comments, concerns, complaints, by all means, please email me. I get back to you very soon. Otherwise, thank you very much, and I will see you guys around.